What if the most important machine humanity has ever built is about to go silent forever? And the only people who can stop it have never tried what they're about to try. Right now, a small team of engineers in California is racing against a clock that started ticking 49 years ago. If you want to see how this story ends, don't scroll past this. Hit like right now, not because I asked nicely, but because this channel only survives if people like you refuse to look away from stories that matter. Subscribe if you want to know the moment this attempt succeeds or fails. Share this with one person who still looks up at the night sky and wonders what's out there. Now let's get into it. To understand why a handful of engineers are betting everything on an experiment they've never tried before, you have to go back to where this all started. In September 1977, a spacecraft the size of a small car left Earth. It was called Voyager 1. Nobody expected it to still be talking to us today. The mission was supposed to last 4 years. Fly past Jupiter, fly past Saturn, take pictures, gather data, and then fade into the background of space history like so many other probes before it. That's not what happened. Voyager 1 flew past Jupiter in 1979 and Saturn in 1980. And instead of falling silent, it kept going, it kept transmitting, it kept working, and it just never stopped. Today, in the summer of 2026, Voyager 1 is roughly 16 billion miles from Earth. To put that number in perspective, light, the fastest thing in existence, the thing that crosses the entire diameter of Earth in less than a quarter of a second, takes almost 23 hours to travel from Voyager 1 back to us. Every single command NASA sends has to travel for nearly a full day before it even reaches the spacecraft. Then whatever Voyager 1 sends back takes another day to return. A single question and a single answer takes almost 2 full days, round trip. Think about trying to fix a machine, a fragile, aging machine, when every single test you run costs you 2 days just to find out what happened. Voyager 1 is moving away from us at about 38,000 miles per hour. Even at that speed, if it were aimed at the nearest star system, it would take more than 70,000 years to arrive. It isn't aimed at anything. It's simply drifting, forever, carrying a golden record filled with human voices, human music, and greetings in 55 languages, in case anything out there ever finds it. But here's the part that most people don't know. In August of 2012, Voyager 1 did something no human-made object had ever done. It crossed the heliopause, the invisible boundary where the sun's influence, the solar wind that surrounds our entire solar system like a bubble, finally gives way to the vast emptiness between the stars. Voyager 1 didn't just approach that boundary, it crossed it. It is right now floating in true interstellar space, not near it, in it. It is the only instrument human beings have ever placed directly into the space between stars, and it has been sending back data from that region for over a decade. That's the achievement. Now here's the problem. Voyager 1 runs on power generated by the slow radioactive decay of plutonium, not solar panels. This far from the sun, sunlight is far too weak to be useful. Instead, 3 small generators aboard the spacecraft convert heat from decaying plutonium into electricity. When Voyager 1 launched in 1977, those generators produced about 470 watts. That's barely enough to run a couple of hairdryers, and it was meant to power an entire spacecraft exploring the outer solar system. Today, that number has fallen to roughly 250 watts, less than half of what it started with. And here's the part that should make your stomach drop a little. That number will never go up again. It can only go down. This isn't a mechanical failure that can be repaired. It's physics. Plutonium decays at a fixed, unchangeable rate. Every single year, Voyager 1 loses about 4 watts of usable power. 4 watts. Less than a single dim light bulb, but on a spacecraft with almost nothing left to spare, 4 watts a year is the difference between an instrument staying alive and an instrument going dark forever. Because of this slow, permanent bleeding of power, the team at NASA's Jet Propulsion Laboratory has had to make brutal decisions for years. Voyager 1 launched with 10 scientific instruments. 7 of them have already been shut off, not because they broke, because there simply wasn't enough electricity to keep them running alongside the systems that keep the spacecraft itself alive. These systems include its heaters, its transmitter, and its onboard computer. Years ago, long before this crisis reached its current point, the science and engineering team sat down and made a plan. They mapped out, instrument by instrument, which ones would be sacrificed first, and in what order, to squeeze the maximum possible science out of a dying power supply. It was, in a very real sense, a plan for how a machine would slowly lose its senses, one at a time. Its makers tried to preserve as much of its awareness as they possibly could for as long as they could. That plan worked for years. And then, on February 27th, 2026, everything changed. It was supposed to be routine. Engineers sent Voyager 1 a simple command to adjust its orientation in space, something the spacecraft had done countless times over the decades without incident. The command was received, the maneuver began, and then something nobody expected happened. Power levels dropped. It wasn't a huge drop. But on a spacecraft where every fraction of a watt is already accounted for, any unplanned drop is not a small inconvenience. It's an emergency. Because built into Voyager 1's decades-old electrical system is an automatic safety mechanism. This piece of 1970s engineering was designed to protect the spacecraft if it ever tries to draw more power than its generators can supply. If that system triggers, it doesn't ask permission. It doesn't wait for a decision from Earth. It starts shutting things down on its own immediately, based on rules written half a century ago. And remember the communication delay. Nearly 23 hours for a signal to reach Voyager 1. Another 23 hours for a response to come back. If that automatic safety system had triggered during the power drop, engineers on Earth wouldn't have known about it until an entire day after it started happening. By the time they found out, the spacecraft could have already shut down systems in an order nobody planned for. It could have shut off something they never intended to lose. In the worst possible version of that scenario, it could have damaged something that can never be recovered. The team at JPL understood exactly what they were looking at, and instead of waiting to see what would happen next, they made a hard decision on purpose, before the machine could make a harder one by accident. On April 17, 2026, engineers sent a command to permanently switch off one of Voyager 1's last remaining instruments, a device that had been measuring charged particles, cosmic rays, and ions continuously since the day the spacecraft launched in 1977. 49 years of uninterrupted data, some of it from a region of space no other instrument has ever reached, gone dark by choice to protect everything else. The mission manager overseeing Voyager described the decision honestly. Turning off a working science instrument is never something the team wants to do. But given everything else on the line, it was the safest option they had left. Not a good option, the least bad one. That left Voyager 1 with only 2 working science instruments. 2 out of the original 10. A device that listens to vibrations in the plasma of interstellar space, and a device that measures magnetic fields. That's all that remains of the most ambitious instrument package ever sent beyond our solar system. But here's something small the engineers did that tells you everything about how they think. Even after shutting that instrument down completely, they left one tiny component attached to it, still running. A motor that uses less than a single watt of power. Almost nothing. But they left it on, deliberately, because of what they were already planning next. If you've made it this far, you already care more about this story than most people ever will. So let's talk about the plan the engineers have been building for months. The plan they call, quite literally, the Big Bang. The name isn't poetic. It's not a tribute to the origin of the universe. It's a description of exactly what the plan involves. A single, simultaneous, all-at-once rewiring of how electrical power flows through every remaining active system on Voyager 1. Here's why that matters so much. Voyager 1's electrical system was designed using 1970s engineering thinking. At a time when the spacecraft had over 400 watts to work with, efficiency was not the primary concern. That system was never built to be efficient at 250 watts. And it certainly wasn't built for a future where the power keeps shrinking every single year with no way to stop it. Buried inside that old design are pathways, routes that electricity takes from the generators to individual systems, that waste small amounts of power. 50 years ago, those small losses didn't matter. Today, they might be the exact difference between an instrument staying alive and going permanently dark. The Big Bang Plan is an attempt to reorganize those pathways. Not slowly, not one system at a time, but everything, all at once, in a single coordinated switch. And here's why they can't just ease into it gradually. If they change one pathway while leaving the others untouched, that in-between state could accidentally trigger the very same automatic safety shutdown they're trying to avoid. The temporary half-finished configuration is the dangerous part. The only way to skip that danger zone is to jump straight from the old configuration to the new one in a single move. No gradual transition, no safety net, no one attempt. Now think about what that actually means for the people planning it. They are proposing to flip the entire electrical architecture of a 49-year-old spacecraft, all at once, from a distance of 16 billion miles, using a communication system where every single command takes nearly a full day just to arrive, and where they won't know if it worked or if it failed catastrophically until almost 2 days after they send it. There is no pausing halfway through to check. There is no calling it back once it's sent. It either works or it doesn't, and by the time they find out which, it will already be over. Given how much is riding on this, the engineers made a decision that tells you exactly how careful they've been. They refused to try it on Voyager 1 first. Voyager 1 has a twin. Voyager 2 launched just 16 days earlier, in August 1977, but it took a different path through the solar system, flying past Uranus and Neptune before heading outward. Because of that different route, Voyager 2 is actually closer to Earth today, around 13 billion miles away instead of 16 billion. It crossed into interstellar space 6 years after its twin, in November 2018. It currently has a slightly larger power cushion, Small differences, but enough to make it the safer place to test something this dangerous for the very first time. So that's exactly what the team is doing. Testing the Big Bang procedure on Voyager 2 first, running the tests through May and June of 2026. If those tests succeed, if the power reroutes the way the simulations predict, only then will they proceed. If nothing unexpected triggers the automatic shutdown system, the test is a success. If the efficiency gains show up the way the calculations say they should, the team will move forward. Only then will the team attempt the same procedure on Voyager 1, no earlier than July 2026. One of the scientists closely tied to the shutdown instrument put it simply: if this plan works, there's real hope it could power that instrument back on, and let researchers keep learning whatever else is waiting out there in that distant, barely explored region of space. Whatever else is waiting. That phrase carries more weight than it sounds like. Because Voyager 1 has spent 49 years constantly finding things nobody expected to find. All right, before we go further, I need 60 seconds of your time. If this story is making you feel something, curiosity, worry, awe, any of it, that feeling is exactly why this channel exists. Smash the like button so more people see stories like this instead of noise. Subscribe so you don't miss what happens when the Big Bang procedure is actually attempted. And if you know someone who loves space, who loved Voyager as a kid, send them this video right now. They'll thank you later. Let's keep going. Now, let's talk about why any of this actually matters beyond just keeping an old machine alive a little longer. Because the honest answer isn't sentimentality. It's science that we cannot get anywhere else in the entire universe. Since 2017, Voyager 1's plasma wave instrument, one of the two still working, has been detecting something strange. A steady, continuous hum in the plasma of interstellar space, not a burst triggered by some specific event, like a solar storm sending a shockwave outward. A constant, ongoing signal that has now been detected across hundreds of millions of miles of interstellar space year after year with no clear explanation. Scientists have two competing theories about what's causing it. One possibility involves plasma particles vibrating naturally in response to their surrounding environment. The other involves a completely different mechanism tied to the random thermal motion of electrons. One that would force scientists to rewrite parts of how we understand the space between stars. Figuring out which explanation is correct requires more data, ideally cross-referenced with particle measurements from the very instrument that just got shut down in April. Without that instrument running, one half of the picture is simply gone. If the Big Bang plan works and that instrument comes back online, scientists can start cross-referencing that data again. If it doesn't, that particular mystery may sit unsolved for a very long time, maybe permanently. Because there is nothing else out there capable of measuring it. And this isn't just an interesting academic puzzle. The region Voyager 1 is studying, the interstellar medium, directly shapes something called the heliosphere. The massive bubble of solar wind that surrounds our entire solar system and shields every planet, including Earth. It protects us from the harsher radiation that fills the rest of the galaxy. If the interstellar medium out there is more turbulent, more structured, more unpredictable than our models currently assume, then the heliosphere protecting us is more variable than we thought too. And that has real implications for understanding the radiation environment that has shaped life on this planet for billions of years. It also affects what it might look like going forward. This is not abstract. This is about understanding the shield around our own home. Here's the part that makes all of this even more urgent. There's no backup mission, nothing waiting in line to replace Voyager 1 when it finally goes silent. NASA scientists have proposed a dedicated interstellar probe, a modern spacecraft built specifically to study this region. It would have far better instruments than 1970s technology could offer. The scientific case for it is strong. Researchers support it. But as of right now, in 2026, that mission exists only on paper. No funding, no launch date. And even if that changed tomorrow, even if NASA approved it and built it as fast as humanly possible, using the most aggressive trajectory design available, it would still take roughly 25 years, just to reach the boundary Voyager 1 already crossed back in 2012. 25 years. That means whenever Voyager 1 finally stops transmitting, there will be a gap of decades, not years, before any other instrument reaches that same region of space again. During that entire gap, the map simply stops. The questions Voyager has raised but never fully answered will sit there, unanswered, in silence, for an entire generation. That's the real weight behind this whole story. The Big Bang procedure isn't just about extending the life of one old spacecraft for its own sake. It's about holding open a window into interstellar space. Once it closes, it will not open again for at least a generation. I want to pause here and say something directly to you because I think it matters. Most videos about space either overhype things that don't deserve it, or they underplay things that absolutely do. This is one of those rare moments in modern science where the stakes are genuinely as high as they sound. And I'm not going to pretend otherwise just to keep you entertained. If you've watched this far, you clearly want the real version of the story, not the exaggerated one. So do me a favor, drop a comment with just one word, signal. If you're rooting for this to work, I read every single one, and I want to know how many of us are actually paying attention to this. Now, if you're wondering whether this team even has a real shot at pulling off something this risky, the answer is yes, and here's why. This isn't the first time Voyager 1 has stared down what looked like a mission-ending crisis. In November 2024, a routine command meant to activate a heater accidentally triggered the spacecraft's automatic safety system. Voyager 1 switched away from its primary radio transmitter, the one it had relied on for decades. It switched over to a backup transmitter that hadn't been used since 1981. 43 years of complete silence on that backup system. Nobody currently working on the mission had ever operated it in real use. And yet the team figured it out. They recovered full communication using hardware that predated most of their own careers. Before that, in late 2023, Voyager 1 suddenly began sending back garbled, unreadable data. Corrupted noise that continued for months while engineers tried to figure out what had gone wrong. Eventually, they traced it to a single deteriorated memory chip, damaged after nearly 5 decades of exposure to cosmic radiation. The fix wasn't simple. Engineers had to rewrite the affected software. They physically relocated pieces of code into different sections of memory that still worked, essentially rebuilding part of a computer's brain from 15 billion miles away using programming languages that most people alive today have never even heard of. It took months of patient, careful work. It worked. Before that, there were thruster failures that shouldn't have been recoverable but were. Attitude corrections that pushed 1970s hardware far beyond what it was ever designed to handle. Power calculations revised again and again as the generators kept fading, year after year without pause. 49 years of problems that looked unsolvable on the day they appeared, and solutions that a small, dedicated team found anyway, every single time. The Big Bang is simply the newest chapter in that same fight, the most ambitious attempt yet, the riskiest one yet. But it is not being attempted by a team that panics under pressure. It's being attempted by the same people, and in some cases their successors, who have spent decades proving that they don't give up. They don't stop just because a problem looks impossible. There's one more date you need to know because it's coming soon and it's going to matter. On November 18th, 2026, at 2:16 in the morning Pacific time, Voyager 1 will officially become exactly one light day away from Earth. One light day. The exact distance that light itself needs a full 24 hours to cross. Light moves at 186,000 miles every single second, the fastest speed physically possible anywhere in the universe. Just over 16 billion miles. Think about what that actually means. A command sent from Earth on a Monday morning won't reach Voyager 1 until Tuesday morning. Whatever Voyager 1 sends back in response won't arrive back on Earth until Wednesday morning. A single question and a single answer, one full round trip, will take 2 entire days. Every test, every diagnostic check, every adjustment the team wants to make to the spacecraft's fragile systems will cost 2 days. They have to wait 2 days before they even know what happened. That's the environment this final Big Bang attempt is happening inside. Not just distant in a way that makes real-time problem solving completely impossible. And that distance keeps growing. Every single day, Voyager 1 moves a little farther away, forever. The one light day milestone isn't an ending point. It's simply a way to measure the distance. It shows just how far the signal has traveled to reach us and how much farther it will keep going. I think about this a lot, and I want to leave you with the way I actually see it. In 1977, a group of engineers built a machine using slide rules, paper calculations, and computer technology that had less processing power than a modern calculator. They built it to last 4 years. They gave it a golden record full of human voices and human music. A message in a bottle thrown into an ocean so large that the chances of it ever being found are almost impossible to calculate. They weren't building it to make history-defining discoveries. They were building it to explore, to say hello, and then to quietly fade away like every mission before it. Instead, it kept going. It crossed into a region of the universe no human instrument had ever touched. It found a wall of unexplained heat at the edge of our solar system. It detected a mysterious, unexplained hum drifting through the plasma between the stars. It found magnetic connections between our sun and the wider galaxy that nobody predicted. 49 years later, it is still talking to us. And a small team of engineers is refusing to let that conversation end without a fight. Right now, as you're listening to this, tests are running on Voyager 2. Checking whether an untested, unprecedented power reconfiguration can work on hardware built half a century ago. If it works, the same procedure will be attempted on Voyager 1 in July. If that works too, there's a real chance the instrument silenced back in April could come back to life. The only human-made device ever placed in interstellar space could keep listening a little while longer. Nobody knows yet how this ends. Not the engineers, not the scientists, not anyone. That uncertainty is exactly why this moment matters so much. We are watching, in real time, whether human ingenuity from the 1970s can be stretched just far enough, just one more time, to outrun the slow, unstoppable physics of a decaying power source 16 billion miles from home. If this story moved you even a little, don't let it end here. Hit like so this reaches more people who need to hear it. Subscribe and turn on notifications, because when NASA confirms whether the Big Bang procedure worked, you'll want to know immediately. Don't wait weeks later for it to be buried in some algorithm. And share this with someone who still remembers looking up at the sky as a kid and wondering what was really out there. Because right now, one small machine is still out there. Still listening, still speaking, still refusing to go quiet. 16 billion miles away, a signal is traveling toward us right now. It will take almost a full day to arrive. And when it does, somewhere in Pasadena, a team that has never stopped fighting for this spacecraft will be waiting to hear what it says. The signal hasn't stopped yet, and as long as it hasn't, neither will they.